Finally, in this last video, we're going to look at the last two pages where we have some proofs. Number 45 here says, given that L is parallel to M, and given that angle 4 is equal to angle 3, we need to try to prove that angle L and angle P are parallel. Now, whenever we're given a proof where we're filling in the blanks like this, we need to look at someone else's plan for how to get there, not just our idea of the best way to get there, but what was someone else thinking, and use the information they left us. So first one that we always need to get right no matter what is to write our given statement in. So L is parallel to M and angle 4 is equal to angle 3. Don't get that one wrong, that's 3 points. Now the next part says angle 4 is equal to angle 2. Somehow from the given information we know that. Now before we go too much further, I want to mark up this picture with the given information. So L and M are parallel. Put little parallel marks on there. Angle 4 and angle 3 are equal to each other. Mark that too. So now we're also told that angle 4 and angle 2 are equal to each other. Now based on the information in the picture, I see I have parallel lines, and those two, angle 4 and angle 2, are corresponding angles. So parallel lines must be giving us corresponding angles. So we can say parallel lines give us corresponding angles being equal. So corresponding angles are equal because of those lines. Now we have a substitution. So this next step, we have to use equations we already have and do some substitution with them. Nice thing is we only have two equations. So it's pretty hard to goof this up because we really don't have many options. We have angle 3 and angle 4 being the same. We have angle 2 and angle 4 being the same. So therefore it must be angle 2 equal to angle 3. That's the only substitution we can actually make with the equations that we have. And then finally, last step, we suddenly proved that L must be parallel to P. Well, let's mark on our picture the information we just found out here, that 2 and 3 are the same. If we know that angle 2 is equal to angle 3, those two angles, which would be corresponding angles on these lines, would prove that the lines are parallel. If the corresponding angles are equal, we get the parallel lines. So we're going to say that corresponding angles are equal gives us parallel lines. It is exactly what we wrote for number 2, but the order is flipped. Here parallel gives us corresponding, here corresponding gives us parallel. So just be careful with little details like that. So that one's pretty quick. Go on to the next one here. We are given that angle 4 and angle 5 are the same. We are given some parallel lines, and we need to prove that two angles are equal. Now the first one, again like above, is always going to be the given. So they give us what the given is. We just write the word given as our reason. Second step, we always want to mark up our picture right away. So we're given that 4 and 5 are equal. We are given that RF and EY are parallel. So we know those lines are parallel, we know those angles are the same. We want to prove that angle 5 and 1. That's what we want to get to, is that 5 and 1 are the same. So we are told that parallel lines imply corresponding angles are equal. Parallel lines gives us equal corresponding angles. Well, let's look at what corresponding angles we might have that go along these two lines. Since our only transversal is going to be this one here, our only corresponding angles would be angle 4 and angle 1 along that transversal. So angle 4 and angle 1 have to be the angles we're talking about. Last step says substitution. So whenever we have a substitution, we look at equations that we've previously written down, and that's all we can draw from. So this one and this one are only two equations. So since they're both equal to angle 4, angle 1 equals angle 5. Now since it's our last step, this should be what we are trying to prove. And sure enough, look at that, it is. So substitution always uses stuff before it. The last step, the statement, should be what we're trying to prove, and it does match up. Finally, this last one here, it says find the midpoint of this triangle, prove that the segment is a perpendicular bisector. Remember, perpendicular bisector would go through and meet at a 90-degree angle and split this into two equal pieces. So we already have the fact that it's two equal pieces because we're finding the midpoint. So we're proving it just by finding the midpoint. The really hard part is proving that the segment is a perpendicular bisector that goes through this triangle. So when this line goes through this line right here, what we're trying to prove is that it actually meets at a 90-degree angle, or the slope of this and the slope of this are the opposite reciprocals of each other, the negative flip of each other. So let's go ahead and find that midpoint. What is halfway between 0 and 2x? We can write it out, 0 plus 2x, and then we're going to divide that by 2. Same thing with the y's. We have 2b and 0, and we're going to average those out as well. So 2x is what the sum is. We divide that by 2 and we just get x. 2b divided by 2, we get b. So this is our midpoint. Now let's find our slope of the midsegment. Slope of the midsegment, we are going to go from 0, 0 to xb. So the distance between our y's is b. Distance between our x's is x. So our slope, and it's going upwards, so our slope is b over x. Our other segment here, let's find the slope of that. Distance between our y's is going to be between 0 and 2b, 2b. Distance between our x's is 2x. So that equals, if you cancel out our 2's here, b over x. And that slope is negative, going down, so it is negative. Now here is where we need to be careful. We want to prove that the negative flip of one of these is equal to the other one. Now the negative flip of this is going to be x over negative b, or negative x over b. That is not the same as this. So essentially, we tried to prove this, but it is actually not true. We cannot prove it. It is a false statement. And let me just show you a quick example of what it might look like to disprove that. If b and x were the same, it would work fine, and that's why this picture looks like it works. But let's imagine that b and x were not the same. What if your line went something like this, and you found the midpoint here, and you drew a line through that? That is not a 90-degree angle. So when b and x are the same, imagine, for example, if b and x were the same, then you could really just write this as -1 and +1 slope. If this is +1, this is -1, yeah, they are going to be perpendicular. But any other numbers besides them being equal, and you'll see that this is going to be either greater than or less than 90 degrees. So we cannot prove it. And in fact, we can give a counterexample right here to disprove it, that this segment that we would be drawing through 0, 0 and through the midpoint is not a perpendicular bisector all of the time.